So I want to go over the domain and range of exponential functions today. Now the first thing I want to point out with is when a is your base and a is larger than 1, this is always going to be an increasing function, or sometimes it's called a growth function. Now, one about things about this is all of these functions are going to have the same points in common. What I want you to look for when you're graphing these is the first common point is going to be this point right here, which is going to be 0, 1, whatever that base is. And that's because no matter what a is, when you raise that to the 0 power, it doesn't matter the base. Anything to the 0 power is always going to equal 1. The next point that's going to be really important with here is when the x value is equal to 1, then whatever a is will be up here someplace, and that will be at 1, a. And that's because, again, with whatever a is, if my x value is 1, that just equals a. And then the last piece that we want to talk about this is what happens if it was a to the -1 power. Well, that's the reciprocal, so that would be 1 over a. So over here at -1, that would be -1, 1 over a. And this will always be your function. And again, this is for any value of a. So some examples of what that would look like, that could be f of x is equal to 3 raised to the x. It could be g of x is equal to 10 to the x power. And it could even be h of x is equal to e to the x power, because e is a value, e is a number. What does the domain and range look like for this? So the domain is all x values, so the domain goes from -infinity to +infinity, and the range is only positive values, so the range goes to 0, and I want parentheses around 0 because 0 is not included, and that goes to +infinity. Now, the next one we want to look at is, what if a is not larger than 1? If a is between 0 and 1, remember it can't equal 0, and for you to have an exponential function, the base cannot equal 1. So let's go ahead and take a look at this. This is going to be a decreasing function or a decaying function. So we're going to still look at those same points for x and y, but we have -1, 0, and 1. So let's just talk about the -1 for a second. If you have a to the -1, that just equals 1 over a, which would put us over here at -1 and whatever this particular value of a is. But if we're looking at a real life example, an example of this would be 1/2 raised to the -1 power. Or the reciprocal of that, which would be 2 over 1, which is 2. All right? So this would be 1 over a, but a real world example for this, if a was equal to 1/2, would be 2. That's why it's a little bit larger here. The other 2 points that we have are the same as before. Anything to the 0 power is equal to 1. And the last one, anything to the first power is equal to itself. But with this, remember, it's getting smaller. The domain for this is the same, -infinity to +infinity, same thing with the range. The domain goes from negative infinity to positive infinity. In the range, still everything is positive, so it goes from 0 to infinity. We're going to go ahead and look at some general rules for the shifting of this parent function. The first being if it shifts d units vertically, and the shift is in the same direction as this sign. And with this, remember that whatever c is, it goes horizontally in the opposite direction. All right, now the y-intercept is a point you always want to use. And that means you just plug in 0 for x. This also gives us our range. Our range goes from d to infinity. And the domain remains unchanged. The domain is going to be negative infinity to positive infinity. So let's go ahead and put all of this together. What are the shifts that I have here? So the shifts are identified by C and D. So it's going to be minus the C and then D for the shifts. So what that tells us is 1 is C, but I have to change that sign, so that's going to be in the opposite direction. So that's going to be -1. And for D, that goes in the same direction, so that's going to be -3. So that tells me for the shifts, what I have is 1 unit to the left and 3 units down. The horizontal asymptote is just y is equal to d. We already identified d as being -3, so that is just going to be y is equal to -3 for the answer for this one. The domain is still the same. The domain goes from negative infinity to our positive infinity. So this is our answer for our domain. And the range goes from d to infinity, which in this case is just going to be -3 to infinity.